All right, so today we're going to take a look at this thing called the first derivative test. The first derivative test is very similar to what we were doing earlier in the week, where we were finding our critical points and then looking for the increasing and decreasing intervals. But really what the first derivative test is, it's going to bring it all back together to talk about what an increasing to decreasing interval or a decreasing to increasing interval really means. So here's a nice image that kind of gives the idea of what's going on here with our first day of the first derivative test. If we see a negative sloped curve stop, right, the slope becomes 0 at this point C down here and then turns positive, what we have is a minimum, right? We call this a relative minimum. And then it's the same thing over here. We see a positive sloped graph, right? The derivative is positive. It turns 0 at that point C and then turns negative. We have a maximum, right? It just makes sense. If a graph is going up and then curves back down, maximum. Going down, turns back up, we have a minimum, right? You guys have seen that in the graphs for years now. Now we're going to take a look at what does this mean in terms of the slope and the derivative of the function. So let's take a look at an example here. So one example says find all the relative extrema, which is just the plural of extremes, of the maxes or mins of the function f of x is equal to 2x cubed minus 3x squared minus 36x plus 14. So what we first need to do is find those critical points. And in order to find those critical points, we got to find the derivative, so f prime of x, and set it equal to 0. So f prime of x is equal to 6x squared minus 6x minus 36. And then we set this equal to 0. So 0 equals 6x squared minus 6x minus 36. We could factor out that 6. We have x squared minus x minus 6. Then we can factor here, x minus 3 times x plus 2. And we find two x values, or two critical points, one at 3 when x is equal to 3 and one when x is equal to negative 2. So like what we were doing with finding the increasing and decreasing intervals, we need to take these critical points and put them on a number line. And we need to investigate what's going on to the left, in between, and to the right of these points. So I'm going to pick a number to the left. I'm going to pick negative 3. I'm going to pick 0 for the middle number, and I'm going to pick 4 for the value after. So in order for us to evaluate these, we need to find f prime at negative 3. Right, so we're going to substitute negative 3 into f prime. You guys can do this in the calculator. You guys can graph it. I myself put it in my y1, and I'm just taking a look at the table. So f prime at negative 3 we find is a positive 36. So what that means is we have a positive value here to the left of the first critical point. Then I'm going to find the derivative at 0. So I'm just looking at my table here, and my derivative at 0 is negative 36. So we could see that this graph has become negative. And then finally, we're going to find f prime at 4. And f prime at 4 is 36. We just kind of found that was the nice symmetrical points. Not always going to be the same numbers there, but we see it goes positive, negative, positive. So over here at that 4, so the values to the right of the 3 are now increasing slopes again. So what we have is a graph that is increasing to the left of our first critical point, then it's decreasing, and then it goes from decreasing to increasing again. So I like to draw these arrows in here because really what it does for me is it shows, hey, I'm increasing then decreasing. And what do we see? We see a maximum. Right? So we know there's a max at this point. Then I see my arrows go from decreasing to increasing. So I could just draw my little curve there, and I see that I have a minimum. So I know that there's a maximum at negative 2, and I know that there's a minimum at when x is equal to 3. Now what we need to do then is find those actual points and identify them. So in order to do that, we need to find what is the value of the function at negative 2 at this critical point. So we substitute negative 2 back into f of x, and when you guys do that, you should get 58. So we know that there is a maximum value when x is equal to negative 2 at 58. So that's the coordinate point, -2, 58 is a maximum. And then we know that there's a minimum value, right? That's minimum value when at f at 3. And when f is equal to 3, we get -67. So we know that the coordinate point 3, -67 would represent our minimum value. So what you guys are going to do is take a look at looking at this first derivative, getting an idea of whether it's increasing, decreasing, or decreasing to increasing to help find those maximums and minimums. Now, you can have more than one maximum, you can have more than one minimum, so it's okay if you do get multiple. So take a look, try a couple practice